In this video, we will understand the concept of area related to plane figures. Let's start with the basics. First is plane figure. Plane figures are two-dimensional figures created on a flat surface. For example, painting on a wall, stamp on a paper, signboards, all are the examples of 2D figures. Second is the concept of area. The term area originated from Latin, meaning a plain piece of empty land. In geometry, the area of shape refers to the amount of space it occupies in a 2D plane. The concept of area is not only important in maths, but it also has countless real-world applications, like from calculating the area of land in determining the amount of paint needed to paint a wall to cover a surface in the construction sites. Thus, understanding area is crucial in every field. In simple words, concept of area signifies how many unit squares can fit in a given flat surface. For the calculation of area, a grid is used. Moving further, let's understand the grid system. Grid refers to the straight lines that crosses each other to form equal squares. The grid consists of many squares and each square has side equal to 1 unit, resulting in the area of each square as 1 square units. One can change the side of each square by increasing or decreasing the gap between the lines in a grid, or it can be done by changing the units of length, that is, centimeter to inches or feet or meter. For now, grid lines with the difference of 1 centimeter is used, resulting in the area of each square as 1 square centimeter. For the calculation of area using grid, draw shapes on the grid whose area has to be calculated. The area of the figure is counted as the number of unit square within the shape. For the calculation of number of squares that are considered, there are certain rules. Rule 1 states that if the squares that are fit in a given figure are complete, then the area equals to the number of squares it has. Rule 2 states that in case the squares that fit in a given shape are more than half, then those squares are considered as 1. For example, in this triangle, both bottom extreme squares are partially more than half, so they are considered each as 1. Rule 3 states that if the square that fit in a given shape is less than half, then the square is neglected, as the topmost and second topmost squares in the extreme are less than half, so they are rejected in the calculation of the total area of the given triangle. Thus, the area of triangle equals 12 square units. Similarly, in the next figure, total number of complete squares equals 16, number of half squares equals 8, which on simplification gives 4, more than half squares equals 8, and number of squares less than half equals 4. Therefore, the total area of the given figure equals 28 square units. Moving on to the next figure, here total complete squares equal 12, number of half squares equal 4, which on simplification gives 2, number of more than half squares equal 8, and number of squares less than half equals 8. Therefore, total area of the given figure equals 22 square units. Using the grid system to calculate the area is quite easy, but it only gives the approximate value, and it requires the time in analyzing the different squares that fit into a given shape. However, this system is easy to calculate the approximate areas of irregular shapes. For example, area of a leaf. To have the exact areas of regular 2D shapes like rectangle, square, parallelogram, rhombus, trapezium, some standard results are formulated. Let's discuss each one of them in detail. First one is rectangle. As rectangle is a quadrilateral with pair of opposite sides as equal and parallel, the longer side is called length and the shorter side is called width or breadth. Now consider a vertex as origin of a coordinate system. As all the distances are measured from origin, therefore x-axis represents length of the rectangle while y-axis represents the width of the given rectangle. Now instead of counting the squares, property of multiplication is applied. Hence, area of given rectangle equals the product of length and width, which is equal to 4 into 2.5, which on simplification gives 10 square units. Next is the calculation of area of a square. As square has all sides of equal length, therefore its area is the product of the equal sides. Here the equal sides equals 2.5 units. Therefore area equals 2.5 whole square, which on simplification becomes 6.25 square units. Next is the calculation of area of a triangle. As diagonal of rectangle divides it into two congruent triangles, thus the two formed triangles are equal in area. So area of one such triangle equals half the area of rectangle. As for triangle, length of rectangle acts as the base, while width of rectangle acts as the height for the triangle. Therefore, area of triangle equals half times the product of base and height. Using Cartesian graph, base equals 4 units while height equals 2.5 units. Therefore, the area measures half times the product of 4 and 2.5, which on simplification gives 2 into 2.5. Thus, area of triangle equals 5 square units. Next plane figure is parallelogram. A parallelogram is a quadrilateral with pair of opposite sides as equal and parallel. As in Cartesian system, all distances are measured from origin, so it is difficult to measure the dimension of parallelogram with respect to y-axis. To solve this problem, perpendicular height is constructed from one of the vertex. The side on which this perpendicular falls is called as the base of the parallelogram. Now cut the triangle so formed and join it to the other end, resulting in the formation of a rectangle. Now area of parallelogram is equal to the area of rectangle, which is equal to the product of length and width. For parallelogram, length of the rectangle acts as the base of the parallelogram, while width acts as the height of the parallelogram. On putting the values of base as 4 units and height as 2.5 units, area of parallelogram equals 10 square units. Next plane figure is rhombus. Rhombus is a quadrilateral with 4 equal sides. Now there are 2 ways to calculate the area of the rhombus. Let's understand the first one when base and corresponding height is known. To solve the problem of measuring the dimension of rhombus with respect to y-axis, perpendicular height is produced from one of the vertex. The side on which this perpendicular falls acts as the base of the rhombus. Now cut the triangle so formed and join it to the other end, resulting in the formation of a rectangle. Now area of rhombus is equal to the area of rectangle, which is equal to the product of length and width. For rhombus, length acts as the base of the rhombus, while the width acts as the height of the rhombus. On putting the values of base and height as 4 units, area of rhombus is calculated as 16 square units. Second method to calculate the area of rhombus is by using the diagonals. Diagonals are line segments formed by joining the 2 opposite vertices. Here segment AC and segment BD are 2 diagonals. From figure, the area of rhombus is equal to the sum of area of triangle ABC and triangle ADC. As area of triangle equals half times the product of base and height, therefore on putting the corresponding values, we get area of rhombus as half times AC into OB plus half times AC into OD. As half AC is common, therefore area of rhombus equals half times AC into sum of OB and OD. As segment OB and OD equals BD, therefore this equation is reduced to half times AC into BD. Therefore area of rhombus equals half times the product of its diagonals. Now next plane figure is trapezium. It is a quadrilateral with one pair of parallel sides known as bases and the other pair as non-parallel sides known as legs. For the calculation of the area of trapezium ABCD, produce perpendicular height BE and CF from vertices B and C respectively, resulting in the formation of triangle ABE, rectangle BCFE and triangle CDF. As area of triangle equals half times the product of base and height and area of rectangle equals the product of length and width, on putting the corresponding values we get area of trapezium equals half times the product of AE and BE plus product of BE and EF plus half times the product of FD and CF. As from figure, segment AE equals X units, segment EF equals Y units, segment FD equals Z units and segment BC equals Y units. Therefore, the above equation is reduced to half times X into H plus Y into H plus half into Z into H. As H is the common factor to all the terms, therefore area of trapezium equals H times X by 2 plus Y plus Z by 2. On taking LCM we get H times X plus 2Y plus Z over 2, which is further simplified as H over 2 into X plus Y plus plus Z. As the sum of the segments X, Y and Z equals AD and Y measures BC, therefore area of trapezium equals half into height into sum of parallel sides. So this was it for the video. See you in the next one. Thank you for watching.